We are going to continue with the same chapter, matrices. We are going to do the second part of the chapter called the multiplication of matrices, which is important also. Two matrices A and B are said to be compatible for the product AB if and only if the number of columns in A is equal to the number of rows in B. Meaning, you can multiply two matrices A and B. You can multiply two matrices A and B if the number of columns in A is equal to the number of rows in B. So what you have to do is, if you want to check whether you can multiply two matrices or not, what you have to do is, suppose example A 3 5 minus 1 2. Out here the order of matrix is 2 by 2, and out here order of matrix is 2 by 1. Here you have two rows, two columns, order is 2 by 2. Here you have two rows, one column, so the order of this is 2 by 1. Now check the column of matrix A. Column of matrix A is 2, and check the row of matrix B. Row of matrix B is 2. So these two are equal. So since A is of order 2 by 2 and B is of order 2 by 1, so column of first matrix is equal to the row of second matrix, we can multiply these two matrices. So therefore AB is defined. Okay, the meaning of AB is defined means you can multiply A and B. So two matrices can be multiplied if and only if the order, the column of first matrix is equal to the row of second matrix. Now there is one more thing out here. If A is of order m into n, suppose the order of first matrix is m into n, and B is of order n into p, and the order of second matrix is n into p, then the order of the product matrix will be m into p. So here column is n and here the row is n. So now the product matrix, the answer which you get will have the order m into p, m by p. Okay, for example out here the order of A is 2 by 2 and order of B is 2 by 1. So therefore the order of AB will be 2 by 1. 2 by 1, the uncommon one, 2 by 1. Second example I am giving you, C is of order 2 by 2 and D is also of order 2 by 2. So number of columns out here is 2 and number of row out here is 2. So order of C is 2 by 2 and order of D is 2 by 2. So therefore CD can be defined. That means you can multiply CD and the order of the product matrix. The product matrix, the answer matrix will also be 2 by 2, 2 by 2. Now one more example I am giving you. The order of E, out here there are two rows and two columns. Out here there is one row and two columns. Now see, the number of column out here is 2. Since the order of F is 2 by 2 and order of F is 1 by 2, and the number of row out here in F is 1. So number of columns in of first matrix is 2 and the number of row of second matrix is 1. So they are not equal. These two are not equal. So therefore EF cannot be defined. That means you cannot multiply EF.